Welcome to another episode of the Concrete Logic Podcast. And today I have Dan McCoy with me from RL McCoy, bridge engineer, bridge builder. We have some more questions to answer from the Myers Lawson School of Construction at Virginia Tech. Still have a bunch of questions to try to answer for these students. Again, Ashley Johnson, associate professor, sent me these questions, and we've been chipping away at them. So I think the last episode was with Dr. Belkowitz. We tried to answer some of them, and then I did an episode prior to that, and Dan's going to answer some bridge questions for us today. But before we get started, I just want to remind everybody this is a value for value podcast, meaning that I do my best to bring guests like Dan on the show and provide you a value. And then all I ask is if you believe there's a value there, to provide a value back. And there's 3 ways you can do that. You can share the podcast. So share it with a coworker, colleague, anybody that you would think that would get something out of the podcast. And then you could go to concretelogicpodcast.com. There's a couple ways to send me a message. There's a contact button on there. You can shoot me a message. I've had folks do that. There's also a little microphone that you can leave me a voicemail as well. And we actually played a voicemail on the last episode that someone left us and had a guest suggestion. So that was awesome. And then the last way is the donation button that is on the homepage as well at concretelogicpodcast.com. So you can donate any amount. And I just want to thank a couple people that did that recently. So Jason Stubna, I hope I'm not butchering your name, Jason. He donated $25, and he says, thanks for doing what you do for our industry. Really enjoy the guests you have on. Jason, thank you very much. And then my wife donated as well. She's got a weird amount on here. I have to ask her why she donated $12.47. That's an odd amount. Maybe that's all that was in the bank account. And then lastly, I would like to thank Thomas Ginther. He also donated $10.80, and I know he covered the stupid PayPal transaction fee, so it allows you to do that. So I appreciate that, Thomas. Thank you very much. So those folks will be listed as a producer in the show notes. That's how that works. So again, thank you guys for donating to the show. Helps greatly. With that, Dan, let's get into these questions that these students sent over to us. They're really, really great questions. Really impressed with the level of the questions that we received from this group. So this first one, Dan, let's see. I believe this is the first one I sent you. If all the bridges are federally owned, then wouldn't the maintenance of the bridges be up to the government to perform? Now, with a large number of bridges failing throughout the U.S., and if the maintenance was not properly performed, then wouldn't the government be to blame when a bridge collapses? Also, shouldn't the government be allocating more of its resources to fix these bridges promptly? And that is from Dan Charters, and it looks like he's graduating this year. So congratulations, Dan. He's got your name too, Dan.
I could just tell by his name he was a brilliant guy. I could just and the questions are spot on. And it's very confusing to people, how our infrastructure system works. We talked about the time before last time about how the ASCE grades our infrastructure, and obviously it's not just bridges and roadways. They separate those two. And they consider that surface transportation. But the bridges are technically, in 2011, there was a little law passed, and it basically says, I'll summarize it up here, that the bridges are the responsibility of the state that they're in. So the federal government has delegated that responsibility to the states, and they define that, the federal government defines that as any bridge structure that is in use by the public is responsibility of the state. You break that down a little bit more, and then you get into municipalities of local cities and counties. Each state's a little bit different. The state is technically responsible for maintaining and or rebuilding that. The caveat being they are allowed to, or they get funds from the federal government to do this work. And there's kind of this mandated protocol that goes through. It's the National Bridge Inspection Program, or the NBIP. And what those states do then is they can either do the inspections themselves, or they can delegate that inspection. So on a state matter, usually in Indiana, we have state employees that actually are bridge inspectors, and they've been through programs and classes that make them certified as bridge inspectors to be able to rate these structures as, on a scale, so that they can either be considered okay, not okay, structurally deficient, or what areas, even in that inspection, what areas need to be done to maintain or not to avoid a posting or a rating change. And in Indiana, and like many other states, then the state can literally delegate to the counties and the cities, hey, this is your responsibility now to be able to make sure and monitor these bridges in your local municipality. And in Indiana, they have a cumulative bridge fund that is funded every year by the state that are allotted to each county, so that the counties can opt out of it, but that is your help from the state government, and then also it's from federal tax dollars too, to go in and maintain these structures. But there's a lot of bridges out there. There's an awful lot of bridges out there. And to get to the second part of Dan's question, with a large number of bridge failings throughout the U.S. Now, I may have mentioned last time, it's on average that you'll have one structure failure every day in the United States. Now, a lot of them obviously aren't like the Francis Scott Key Bridge, which wasn't what I would consider a structural failure in the classical sense of a structural failure. It was more of accident or incident-related collapse. But you do have at least one structure that's brought out either because it's just aged itself into inadequacy, or there are other environmental reasons for this collapse. Like there's a lot that has to do with washout and scour. There's a lot. You take something out from underneath something and it's going to fall down. That's one. But it's important for everyone to know that the government, I believe, is really trying to do its best when with the resources they have. And it's when I say government, I mean these regulators like the Federal Highway and their local state governments and departments of transportation. I really do think they're doing their best with what they've got. But it is Congress's responsibility, as they hold the purse strings, to fund. And we do get transportation funding. But as the American Society of Civil Engineers will tell you, and it's their job to tell you this because they're an advocate for all of us, is you're not spending enough. And if you wanted to replace our nation's infrastructure since the date that it was passed in 1954 by Eisenhower, you're talking several $1 trillion, not just these $1 or $1.2 trillion bills that were recently passed. I mean, this is all meant, and when we have these fly-ins in D.C., I try to explain to our legislators that it seems like a lot of money, but there is a lot of road miles out there. And one of the things, a lot of us may be listening to this now thinking, well, it's just a way for me to get to and from work. But you got to remember that's a big source of commerce. You being able to do your job is a big source of commerce. So our national transportation system, our surface transportation, is a huge deal when it means on the impact of the economy, which is why we should be taking care of it. And other of it goes, to transportation and trucking. Odds are, if you've got anything in your home or on your house right there, it was delivered at some point by a truck. And they need roads and bridges to be able to move these goods and services across the country. So to be in total agreement with what Dan said, shouldn't the government be allocating more of its resources to fix these bridges promptly? I'm a bridge guy. Of course. Yeah. All of them. No, I'm going to say that, but there are other things that also need attention too. For example, the grid. The grid probably gets a worse rating than bridges and highways, and it continues to, as we continue to add more and more power, and we continue to use more and more power, and then we've got problems with people adding solar panels and their own private being able to push it back into the utility and into the grid causes a lot of problems that's meant for long-term solutions that nobody's really thought up yet in terms of grid solutions. So that's one that's pretty big. And then the other one that goes with our national infrastructure is seaports. And odds are, like I said before, if you've got anything in your house, odds are before it was brought in on a truck, it was probably shipped here. We happen to be a net importer of these everyday goods. So it's one of those that's probably also a lower grade on the list is the seaports, airports, and then obviously surface transportation. So I think overall, this may be worrisome to most, but I think overall the bridges actually have the highest grade in our infrastructure system. Mind you, that's probably a C on a graded scale, A, B, C, D, and F. Everybody else is around a C minus D or an F. But the bridges we're right up there. We're on average. We're around that 75%, 80% mark. So, we're doing our part here. But that's what's important when you consider funding. We're doing all this funding now to maintain, like literally these $1 trillion is meant to maintain most of this. And most of it is in small repairs. We're not adding a lot of new infrastructure, but we're getting to the point of most of these structures were designed with a 75-year design life. And if you look at the implementation being signed in 1954, let's give everybody 5 years to build it and then add 75 years. We're coming up to 2029 and 2030 of most of this, our national infrastructure being structurally obsolescent as far as what they were designed and intended to do. Now, us engineers like to put a large safety factor on things and assume bigger things and worse things happening. So I think we've got more time than that. But, in reality, on paper, theoretically, a lot of this stuff in our entire system should have been changed over at least by 2029 or 2030. And I think as most of you drive around the towns and local communities where you're at, you can probably find that that's probably not the case where you see a lot of new highway, new transportation going in. So to answer Dan's, I hope that answered most of what Dan had in mind for that, as far as how funding works and coming from the federal government down to the state governments. It kind of trickles down, so you can use state funds and federal funds to be able to, and you can apply for more funds if you're a local municipality to be able to help with some of these issues. But it's not like they intentionally run the bank dry on these things. They try to continue to have them funded, but when you only have an infrastructure bill that's only meant to last for 5 years, 10 years, and then you have another infrastructure fight for this stuff, and then you have to share it with the rest of what we consider infrastructure. There's by the time you rain it down and each goes into their individual puddles, bridges are very important, and they are funded for the most part. But do we need more? Yes, obviously. I don't think you'll ever catch me saying no with something like that.
Yeah. And Dan McCoy, we got two Dans going on here. Dan that asked the question and Dan McCoy. Dan shared this website what is this? ARTBA, is that what they call themselves? American Road and Transportation Builders Association. So ARTBA bridgereport.org. If you go to that website, it'll give you a full report on the bridges in the United States, and then you can click on your state. So if I clicked on Virginia, I'll give you a report on the Virginia bridges, tell you how many bridges they are, which ones that are traveled the most, all kinds of data in here. It's pretty cool.
That's probably one of the most fun sites too. And the other little caveat that I really like that they put in there that's checked, you can either view it by state or you can view it by congressional district. And it's amazing how some of those congressional districts are really good and some are really bad. And then you can directly report that to your representative. Hey, why are we so? Why are we in this one? The red is good and the blue is bad, I think.
That's confusing.
It is confusing when you look at it. If you look at the overall ratings, but it's a really cool site. If you can, I know if you're listening on your phone, you can't really do it. But if you know, that would be an awesome link to be able to post if somebody was listening at work.
I'll put it.
Do it. It's really cool to be able to look at that and go, oh, well, I know where this bridge is. And keep in mind, I think this was done in 2021, 2022, something. So some of these bridges may have been worked on and some may be fixed now. But it's kind of nice that somebody is keeping an overall track on the stuff. When you're looking at it, but it's a nice comprehensive thing to realize, like how, like California has, 24,000 bridges. Indiana actually has 19,000. Tennessee and Kentucky are right up there at 19,000, 20,000, and some states don't have a lot, but there's a lot of structures in there. That's a lot to keep track of.
Yeah. No, that's I can personally say I know like around Richmond area, they're definitely working on bridges, and when I traveled down to Virginia Beach, obviously they're doing the big Hampton Roads bridge and tunnel work, and the Chesapeake Bay Bridge and tunnel work. Those are enormous projects, but they're definitely working on it. It's just that work takes a long time.
It does. It does. And the rehab, usually I get questions like that a lot from people like the Brooklyn Bridge and the San Francisco Bay Bridge, the Golden Gate. It's like, how can they build that so fast? And it's like, well, when you're building something brand new, you generally don't have to deal with a lot of people and traffic being around it. But if you're replacing or repairing, that element or that asset, as it's termed, an asset, is still viable and usable, and you want to keep that viable and usable to maintain local commerce through the area and the region, right? I mean, not to get into the Francis Scott Key Bridge, but you see what happens when you immediately close down two avenues of production for commerce. The bridge was closed down, and then because of the bridge being down, you close that entire port. Those problems begin to compound and compound. It's something that you really take for granted because it just works. But then a mistake like that, takes out twofold what's there. So the impact on the local economy is huge. And then because it's a port, the impact on the nation's economy is huge. So when people say, well, what's it worth? Well, what's it worth not to have? What's the cost of not having an element that's meant to do its job that nobody's thought about for 75 years? And then you find out real quick.
Yeah. Well, I know a lot of that cargo traffic that was destined for Baltimore actually ended up in Virginia at the Norfolk terminal. So, and they even the cruise ships that are supposed to go to Baltimore are now coming down here to Virginia as well. So, I guess some of us are benefiting from that tragic event. But I mentioned tunnels, so this next question, Dan,
Sure.
actually is about tunnels and bridges. Are bridges harder to maintain over time than tunnels? Tunnels appear like they would require more maintenance to ensure a cave-in does not happen, but do bridges need more attention over time?
Short answer is yes. There are a lot of ifs in that statement. Bridges are exposed to the open environment a lot more than tunnels are. And usually, if you're dealing with a tunnel, you're dealing with something that was cored through rock, maybe a softer rock, but it was cored through there. So you have the integral structure of the media that you've went through that's providing a lot of the support. So if you can manage the water, which is the ultimate killer for all of our concrete and steel infrastructure, if you can manage the water and the salts that eventually end up causing those long-term corrosion problems, you can actually do fairly well with tunnels as far as maintenance goes. I think the Scandinavian countries have shown that very well. It's just one of the things that they have to deal with, and they've done a very good job at isolating the infrastructure element from the element that they're going through. And when you can do that, you can greatly reduce your maintenance. And when I mean maintenance, I mean your heavy duty maintenance, like replacing panels or replacing structures in the pipe system that may be considered the elements of the pipe tunnel. But if you can constantly maintain a pumping system and a ventilation system, which may take more routine maintenance on a day-to-day factor that you're supposed to account for in the costs, if you can do that, then you're really saving that asset for the long term. You're literally paying pennies a day to keep, a couple $1 billion asset working, which in some of these larger bridges and larger tunnels, what you'll see a lot of the time is it's a toll-based method. So it's a use-based tax on a lot of this stuff, and they end up doing fairly well because the stuff that they do for light maintenance, they can pay for immediately, but then the overflow from that, they can invest in putting into account that actually ends up maintaining the structure over time to an eventual bond or a lease for total replacement in some cases. But yes, bridges are, depending on the design, are a lot more labor intensive to maintain. In the types of applications we're talking about, we're not talking about a bridge down the street from you. We're talking about a bridge over a bay versus a tunnel under a bay. I would say in those two applications, the bridge is going to be a lot more to maintain over time than the tunnel would be. The costs may be a little more for the tunnel in terms of maintenance, but those are everyday preventative maintenance items, replacing pumps, replacing airflow networks. There's a lot of HVAC that goes into that to make it safe. You're essentially going into, it's kind of funny, Seth, we do a lot of safety stuff, and I laugh because, we have these standards that OSHA puts out. This is my caveat. We have these standards that OSHA puts out about, safety railing and fall protection and what those heights have to be. But it's funny, if you walk down an interstate bridge for railing that's meant for a car, the top of that railing doesn't even meet the OSHA standards for guardrail for fall protection, which is kind of funny. And then the same thing for tunnels. We are told as workers, what confined spaces are. And then we have these infrastructure elements where we allow you and your family of 5 to just drive through, basically a confined space. There's a lot of this stuff that us construction workers look at and scratch our heads, and they're used for everyday infrastructure elements. That's just my little caveat. But yeah, hopefully that answered the maintenance question as far as more maintenance or less maintenance. It's a double-edged sword. With the bridges, you're out there every day, or at least once a year. Maybe you're repainting, you're repairing little elements here and there. With a tunnel, it's going to be an everyday maintenance and probably a program of maintenance people that watch that, they're going to view it more as a building than a bridge. You're going to have inspectors that go out and they're going to take attention to detail to certain things. But a tunnel, you're actually going to physically monitor that day to day and make sure that that asset's taken care of. I hope that was as clear as mud to people. And I don't know if I answered the question as to which one you should build given an A or B, because I don't think it's that easy.
Yeah. I think I could sum up your answer by saying it depends.
Yes. That's why I said when you sent that to me, I was like, that's a really tough question, because it's a lot of where's it at, what's it going to be used for, what are the like scenarios.
Yeah.
Obviously, if I'm building a bridge in Antarctica, it's going to require an awful lot of maintenance, a lot more than if I just tunneled through the ice shelf underneath and put concrete there.
Yeah.
So environment has a lot to do with it as well.
But maintenance wouldn't dictate what they build as far as if they had to choose between a bridge and a tunnel.
No.
It depends on what the traffic is going over or under
it's
right?
all transportation based, and for something like the Francis Scott Key Bridge, that's one of the things that you have to look at is, do I have a lot of maritime traffic there? Or, if a tunnel's going under something, let's say it's, a mountain, and then you have a valley between the two, you're going to integrate a bridge with it, or you're going to run that tunnel around that crossing, and end up with some tricky transportation green book problems through a tunnel for sightsee distance and stopping and things like that. But usually it's dictated more so on the needs of the transportation element that you're trying to provide.
Yeah. There's a cool video out there if you just Google Hampton Roads Bridge Tunnel, so HRBT. They just the boring machine, the tunnel boring machine, just broke through its first leg, and
Isn't
they have
that
a
awesome?
video. Yeah, they have the video of it breaking through. That's just pretty cool.
Yeah.
So
you hope your layout guy is right on point with that, right?
Yeah.
And maybe a lot of people don't understand that. Another caveat, right? We've got a whole other chapter where we can go into mining and how mines are made, and tunnels are very much the same way. We go outside and our directions are very easy. We've got northwest, east, south, and we've got bearings and longitudes and latitudes to go by. But guess what? When you go underground, there is no GPS signal. So when you're trying to lay that stuff out and meet certain points and make sure that your position's relevant, it's a little trickier. It's a little trickier doing your layout underground than when you've got clear skies and line of sight.
Yeah, that's amazing technology, that machine. Last question. Say a bridge's foundation, which is concrete, needs to be completely replaced for whatever reason. The foundation is 50 feet underwater in a river that the bridge goes over. How would this be replaced, and what are some common issues that occur while performing this work? Does this happen often? It's a very specific thing. Do you think this is a project this guy's working on?
I think so, or maybe not. You know what? He's going to be really disappointed with the answer. The most cost-effective option is to abandon it and leave it in place. So the new design would not be in conflict with the old foundations. Obviously, you're replacing the foundations, and you can shore that up if you've had a foundation failure. You try to fix that from underneath. But when he says replacement, I'm thinking he's had total failure, which means probably the superstructure is probably in not a good enough shape to save. So usually in things like that, what you do is you avoid conflict with the lower foundations, because a lot of these are 100 plus years old, 80 to 100-year-old. And even if you have the plans, the geotechnical engineering back then was to the point where we really did drive wood piling, 20 or 25 foot wood piling on 3-foot centers. We can't guarantee anymore. We, as in finding an engineer to be able to put a stamp on what the rated bearing capacity I could prove is for a new superstructure going over. So usually what you end up doing, and we've got a few this year where that is the case, but usually what you end up doing is you broaden that out so your open waterway is larger. You end up increasing the span of the superstructure, which means you move your foundations for your new structure out further so that they're not in conflict with the old. And then when it comes to demolition, as you're taking it down, you want to take that to 2 foot below the stream bed. And a lot of times, if you put some turbidity curtains, you have more environmental issues to be concerned with. But if you're going to put a causeway out there and turbidity curtains in to be able to catch debris, you can usually demo that down to 2 feet below the surface, cap it off with usually some form of scour protection, like a large rock, and then you can be able to build your new foundations outside of that to create a larger area. That was not an exciting answer. I think what they wanted was, hey, Dan, how would you do this? So the logical answer is avoid it at all costs, because that does get cost intensive when you do that. But let's just say I had to do that. So we're 50 feet underwater. I don't know what our substrate is, whether we're going into rock, where the rock is. Maybe we're not. Maybe we're looking at something that has a very, maybe it's like a delta condition where it's 50 foot down, but we have a lot of sediment build up over a couple hundred years. And maybe that rock is 40 or 50 feet below where the dredge line of that bottom of water elevation is. And then they're going to hear really cool stuff from me, like, well, I would build a huge cofferdam. And then obviously rail it up around that as we remove the superstructure. Or if we're just talking about, gosh, this is such an interesting question. So let's leave the superstructure alone. Let's say it's in perfect condition. And then let's say that we want to replace this substructure element, this foundation. I can't ever imagine us really having to do this, but this is kind of a cool thought experiment. So you would build temporary supports prior to support the superstructure. And then you would go and you would literally use a cofferdam around that foundation. So you would drive impervious sheet piling around it, maybe secant piling around it, and then you would begin to pump the water out. And then obviously you've got lateral pressure changes that would go in. So you probably have a support probably every 10 feet on the way down. Interior to fight that pressure back, because you would never 50 feet, you'd never find something that would work with that kind of hydrostatic pressure as a single system. So you're supporting it all the way down, you get it down, you dry it out, you have continuous pumps running, and then you begin to rebuild that foundation, and you destroy the cap bent, you build it again, and you work its way back up with probably concrete. And then once you get up in place, you devise a temporary bearing situation, and then cast the concrete in place to fill it in later. And then you pull all the good stuff after you backfill for your foundation, and then you pull the cofferdam and remove the causeway. And as you're removing the causeway on the out, you remove the temporary supports for the superstructure, and finally let it bear on the foundation. I would highly suggest we never do that. But
sounds expensive.
But that's how I would do it.
Yeah.
So most of the time it's mitigation. It's just avoid that problem altogether. And if they have the funds, usually you implement a larger structure. Or sometimes if the flow has changed that much and maybe somebody's flood managed better, or maybe the routes of water have changed in the area, sometimes you can't do this a lot, but sometimes you can actually decrease that span and choke that area down if you can dictate or prove in your calculations that you're not impacting the upstream or downstream water elevation. Specifically, there's a lot of environmental and hydraulics that get involved in the geometry of the structure, at least at the opening of the waterway. Sometimes you can make it smaller, but a lot of times you end up making it bigger.
What if it was just a brand new bridge? How do they pour the concrete in the water?
Well, like I said, a cofferdam.
They do a cofferdam for each
for
One?
each pier. Yep.
Wow.
You would do a cofferdam, or you could, in some situations like back, where you've really got to get down and do the masonry work, if you were going to do masonry, then you're talking about caisson work. And that's a whole different animal in itself. And that is incredibly expensive, obviously. And the safety parameters there, which are also just compound that problem. But usually, if you can open it up to a cofferdam, you can do that because you need to be able to drive piling. Or if you're on rock, you actually need to be able to core into that rock and then set your foundations and then pour that up and then place a mass foundation there. And then be able to work up with your pier and stem system. So yeah, you'd normally surround all that stuff with a cofferdam and then quite literally pump the water out. And there you are in the dry hole in the middle of a river. We do it all the time.
That's great. That's nuts. Huh. Yeah, I was thinking you sleeve it. You would sleeve it like a caisson, but you're saying that's more expensive, huh?
Yeah. Well, it depends. If you're trying to repair, if you're doing something new, it is easy to go out there and put a cofferdam in. It really is. But if you have to work around existing elements, yeah, what you're saying is pretty. Now you can. There's nothing wrong with. We're talking concrete because this is the Concrete Logic podcast. Keep in mind that once that concrete is mixed per ASTM C94, and you're not mixing it anymore, that concrete weighs about 140 pounds per cubic foot, and water weighs about 62.4 pounds per cubic foot. So when you place a heavier substance with a lighter substance, the lighter substance will be displaced, and the heavier substance will sink. So I've seen a lot of people argue that you can't pour concrete in water. Yes, you can. It's going to displace that water. And as long as the cement is hydrated when it goes in, it's not going to take on or change the water cement ratio, as long as you're not still mixing it while it's in that water. But you've literally got, you've literally got your concrete mix good and ready to go. And you're not going to mess with it or mix it in with that water. It will literally displace that water. So there's a lot of operations where pumping underwater is viable, especially for things like a mud sill. If you're going to do that, if you're going to put a cofferdam in and then you want to shore up the bottom from coming in from those lateral pressures, one way to do it is to place a concrete mat foundation down there. It's like not a typical mat foundation, but place a bunch of flowable fill or mortar in there. And then once it cures, it takes compressive stresses extremely well. And then you can begin to pump the water out. So a lot of this fun bridge construction stuff, huh?
Yeah. It's interesting. All right. Well, I think we answered that question. I think we'll or save our other topic for another episode, Dan. But thank you for coming on the show. Is there anything else you want to say about bridges before we go? This is your world. We're talking.
Bridges. Yeah. So I would say to anybody listening that probably the most important thing you're going to do in your daily commute is cross a bridge to get where you're going. And I would just say, thank a local bridge contractor for that. Maybe your local bridge engineer, and realize that we probably are the most important people you meet on a daily basis.
I don't know how you don't argue. I mean,
no, it's just one of those things. A lot of people don't know that they've gone over a bridge until there's a problem with it. It's a thankless job. If you build a bridge right, people don't even know there's a bridge there. But boy, you put a bump in that thing, and man, everybody knows.
Yeah.
It's just one of those things. Whether you're dealing with classic flyovers to make things easier for transportation systems. You see a lot of that in metropolitan downtown areas where you just don't have a lot of real estate to work with. Well, they start building bridges to go over other bridges, in those flyovers. And transportation-wise, it's a wonderful solution to be able to literally stack traffic on top of each other. And it's incredibly efficient. And then you've got other bridges like we were just discussing. Obviously you're going over water. There's There's an element there where you have to maintain that for people to be able to go across an impassable surface for surface transportation. But it's pretty amazing and miraculous when you think about it. The next time you're going down a dirt road, try driving it at 70. For any law enforcement officers listening, I didn't really suggest that. But, if you try going that fast down a dirt road, you'll realize it's almost miraculous that we're able to do 150,000 vehicles per day on an interstate at 75 or 80 miles an hour. You realize what it takes to make that happen. And it's pretty miraculous. And we just consider it to be what it is, when we're out there driving it. But, at some point down that it was a dirt path, and and things like large trucks weren't thought of, and things like, traffic moving at 75, 80 miles an hour, inline, repetitive motion, millions and millions of cycles of load on a structure. It's pretty impressive when you think about our infrastructure system as it exists today, which is probably why it's pretty expensive to maintain. But it does have a value to the community and to the country for moving goods and services. And until we invent a flying car that everybody can use, I think I'm going to have a job. At least
that's a safe bet. All right. I think this is a good spot to end today. Dan, thanks for coming on the show. I will put Dan's contact information on the show notes so you know how to get a hold of him, and also the ARPA link there too, so you guys
that's
can
really
check
cool.
out the.
I would say if the rest of you forget about my information, that's just fine. But open up that website and play around a little bit, and looking at those structures and deficient structures. They'll update that, and then also check the American Society of Civil Engineers. They do a fantastic job of rating our infrastructure every year. They put out a report card, and they get very specific about where the needs need to be met. I would say everybody should probably visit that and just open their mind a little bit about how much we rely on in the infrastructure world to maintain our peace, civility, and stability.
Yep. All right, Dan, thank you for coming on the show. And until next time, folks, let's keep it concrete.